Good morning, my dear students. Today also we are going to discuss about hyperbola. Okay, students. Right now, the length of the lattice rectum of the hyperbola. So, dear students, we have to know that in the ellipse, the length of the lattice rectum is for a greater than b, 2b square by a. So, dear students, when the focal chord is perpendicular to the transfer axis, you see AA dash is the transfer axis. So, student, this is the focus AE comma 0. So, this is the end AE comma y. L dash is the students AE comma minus y. So, students, the point LAE comma y lies on the hyperbola. So, this is the given hyperbola is x square by a square minus y square by b square equal to 1. So, the L is, what is the students? LAE comma y. LAE comma y lies on the hyperbola. Okay, students? L is lies on the hyperbola. So, that is substituting here. This is what? A square e square upon a square minus y square by b square equal to 1. So, students, this is cancelled. Now, students, this will be sending to the other side, that is y square by b square equal to e square minus 1. The plus 1 is sending to the other side. This is e square minus 1. Dear students, now this is what? Y square equal to b square into, what is the e square minus 1? We have to know that the b square is the form a square into e square minus 1. So, student, the e square minus 1 is the b square by a square equal to e square minus 1. So, students, the e square minus 1 can be written as b square by a square. My dear students, this is y equal to, what is there? Y equal to plus or minus b square by a. So, students, what we observe? The L is the here. The L is what? AE comma b square by a. This is L. L dash is the students. What is the L dash is? AE comma minus of b square by a. Now, students, the length of the lattice rectum. What? The length of the lattice rectum is the students LL dash. Can be written as AE minus AE, that is 0, minus of minus plus. This can be written as the students 2b square by a. This is what? Length of the lattice rectum. Dear students, the length of the lattice rectum for the hyperbola is 2b square by a. The length of the lattice rectum for the conjugate hyperbola, that is nothing but x square by a square minus of y square by b square equal to minus 1. Okay, students, this is the conjugate hyperbola whose length of the lattice rectum is the students 2a square by b. This is what? 2a square by b. Okay, students, now the another one is the students, right now we have to know that E1 and E2 are the eccentricity of the, my dear students, E1 and E2 are the eccentricity of the two conjugate hyperbolas. Dear students, if E1 comma E2 are the eccentricities of the two conjugate hyperbolas. What is the students? Eccentricities of the two conjugate hyperbolas. So, then 1 by E1 square plus 1 by E2 square equal to 1. What is the students? E1 comma E2. Dear students, E1 comma E2 are the eccentricities of eccentricities of the two conjugate hyperbolas. This is what, students, we have to know that the E1 Vira, everybody know that. What is the E1? We know that, dear students, the E1 is nothing but, what is the E1? A square plus B square by A square. So dear students, the E2 can be written as, what is the E2? B square plus A square by B square. So students, these are the E1 and E2. Now we have to find 1 by E1 square, 1 by E2 square. 1 by E1 square is the what, students? A square upon A square plus B square. What is the 1 by E2 square is the, students? We can written as B square upon A square plus B square. What is the, students? This is LCM is the equal. Here we taken as, this is what, A square plus B square. So this is A square plus B square. This will be taken as 1. Is it clear, students? 1 by E1 square plus 1 by E2 square. This is, you can written as A square by A square plus B square. This is what, B square by A square plus B square. We can written as A square plus B square by A square plus B square, that equal to 1. Where, students, E1 and E2 are the eccentricities of the two conjugate hyperbolas. Then what? 1 by E1 square plus 1 by E2 square equal to 1. Okay, students? Now, students, I will take one question. What is the equation of the hyperbola whose foci is 6, 4 and minus 4 comma 4? Dear students, just now we observed here, when we are taking the focus is the 6. This is the, students, when you can observe the 6, 4 and this is the parallel to the transfer axis. Undoubtedly, the transfer axis is the, students, what is there here? We observe this is, when we are taking this is 6, so this is the minus 4, yes. What is the, students? When we can observe the, student, this is the hyperbola, yes. This is the, students, when we are taking the 4 is there, 6 comma 4 is the focus, yes. This is the 6 comma 4. This is what, students? Minus 4 comma 4. This is the S dash, this will be the S. Undoubtedly, students, what is the center is? Undoubtedly, center is the midpoint of SS dash. What is the, students? Center of the hyperbola is, we can written as center. Dear students, center will be the midpoint of the center C equal to, we can take as the midpoint of SS dash. Dear students, the midpoint of the SS dash. How can you write the midpoint of SS dash? That is 6 minus 4 upon 2. 4 plus 4 upon 2. This is what? 2 by 2 is the 1. 8 by 2 is the, students, 4. So this is 6 minus 4 is the 2. 2 by 2 is the 1. 8 by 2 is the 4. Center will be the, students, 1 comma 4. Now, students, the 2AE. The 2AE is nothing but SS dash. Dear students, the 2AE, how to write the 2AE? Dear student, this is 6 plus 4 is the 10. Dear student, this will be the 10. Now, students, the AE equal to 5. So, dear students, what we observe? The eccentricity of the hyperbola is given that 2. So, this is what? AE 2E. 2E equal to 5. E equal to 5 by 2. My dear students, this is what? We know that the B square is the form A square into E square minus 1. What is the, students? The B square is the form A square into E square minus 1. So, students, this can be written as the B square. My dear students, the B square can be written as, how to write this is A square. So, my dear students, the B square is the form A square into. So, dear students, E is given that 2. Therefore, this is what? A. E is the 2. Therefore, this is the 2A. Therefore, A is the 5 by 2. My dear student, the B square is the form A square. We can written as this is 25 by 4. E square is the, students, we have to know that e square is the 4. So this is the 4 minus 1 is the 3. Now students, this is 75. Yes, 75 by 4. Now the equation of the hyperbola having the center 1 comma 4 is, we can written as x minus h whole square. That is x minus 1 whole square by a square is the student, this is what? 25 by 4. Minus of y minus k whole square, this is what? Y minus 4 whole square by b square is the students 75 by 4. So that will be equal to 1. Okay students, my dear students, now how can you write this is? We are taking the LCM is the 75. This is the 25 3s are, 4 3s are is the 12. 12 into x minus 1 whole square. After then minus 4 into y minus 4 whole square. The LCM is the 75. What is the students? 12 into x minus 1 whole square minus 4 into y minus 4 whole square. The LCM is the 75. Therefore, that equal to LCM is sending other side. That is 75. Okay, students. My dear students, this is the very important question. The same question will be there in parabola and ellipse also. When the focus, what is the students? When the focus and the directives and eccentricity are given, that the focus is nothing but fixed point and the directrix is called as a fixed line. So the constant ratio is the E. Undoubtedly we can apply the definition of the conic. So my dear students, we have to know that the definition of the conic. What is the student? The definition of the conic is, everybody know that. What is the definition of the conic is? The locus of the point such that the ratio of the distances from the fixed point and the fixed line is always in the constant ratio. So dear students, by the definition of the conic, first we take let p x comma y be a point on the hyperbola. Let p x comma y be a point. What is the students? Let p x comma y be a point on the hyperbola. Be a point on the hyperbola. Let p x comma y be a point on the hyperbola. So students, now here by the definition of the conic, we have to take an as SP by PM. SP by PM equal to E. So students, what is the S is given that the focus will be the origin. So dear students, we are taking SP equal to EPM. So this is what SP. SP is the distance between the 2 points. That is x minus 0 whole square plus y minus 0 whole square. What is the PM is? Perpendicular distance from P to the directrix. P to the directrix is there. X plus y plus 1 equal to 0. PM is nothing but perpendicular distance from P to the directrix. That is what? This is the students modulus of x plus y plus 1 under root of a square plus b square. So students, this is x square plus y square. So the eccentricity also given that. What is the value of eccentricity is the root 2. The eccentricity value is the students is given that root 2. Root 2 cancel. Now this is what? X plus y plus 1. Now students, when you can take squaring on both sides, then it will be the students, what is there? X square plus y square equal to x plus y plus 1 whole square. The x square plus y square equal to x plus y plus 1 whole square. My dear students, this is x square plus y square. So how can you write this is x square plus y square plus 1, a square, b square, c square. Now student, this is 2ab 2xy. This is a 2y. After that 2x. These are cancelled. My dear students, how can you write this is? This is the students 2xy plus 2x plus 2y plus 1. 2xy plus 2x plus 2y plus 1 equal to 0 is the equation of the hyperbola whose focus is the origin and eccentricity is the students root 2. Yes, and the directrix is the x plus y plus 1 equal to 0. Let p x comma y be a point on the hyperbola. By the definition of the conic, sp by pm equal to e, that is sp equal to epm. Sp is the distance between the 2 points. Pm is the perpendicular distance from p to the directrix. Okay students, after squaring on both sides, we got that one. Okay. Now students, find the foci, directrix and LLM of the equation. Right now students, the given equation we can written in the various forms. 9x square minus 16y square 722x minus 32y minus 16 equal to 0. Dear student, this is what? 9 is the common. X square. So now we are taking the 16 from the y terms. This is y square plus 2y equal to 16. What is the students? 9x square, 9x is 72. This is minus 16y square, minus into minus plus. My dear students, this can be written as 9 into x square plus 2 into x into 4 plus 16. Minus 16 into students y square plus 2y plus 1. This is the 16. Yes. What is the student? 16 into 9. 144. This is what students? Minus 16. My dear student, this can be written as x plus 4 whole square. 9 into x plus 4 whole square. This is the students minus 16 into y plus 1 whole square equal to 144. So students, how can we write this is x plus 4 whole square by 16. So this is what students? Y plus 1 whole square by 9 equal to 1. So my dear students, here we can observe the center will be the minus 4 comma minus 1. So what is the students? The center will be the minus 4 comma minus 1. Yes, this is the center. So dear students, first we have to find the eccentricity. How to find the eccentricity is the students? A square plus b square upon a square. This is student 16 plus 9 by 16. So this is 5. So students, the center will be the h comma k. So this is the students h comma k. Now how to write this is the foci. The focus can be written as, how to write the focus? H plus or minus ae comma k. What is the students? H plus or minus ae comma k. So students, the h will be the minus 4 plus or minus. The a is the students 4. This is the 5 by 4. Dear students, what is the k will be the minus 1. So students, minus 4 plus or minus 5 comma minus 1. Now student, this is, what is the foci? The focus is the students, s will be the minus 4 plus 5 is the 1 comma minus 1. And the s dash is the students minus 9 comma minus 1. These are the focus. 1 comma minus 1 and minus 9 comma minus 1. So students, what we observed here, this is the focus. Now we have to find the directrix, equation of the directrix. The equation of the directrix are, we know that the equation of the directives are the form x equal to h plus or minus a by e. What students? X equal to h plus or minus a by e. This is what? X equal to h plus or minus a by e. What is the value of h is? Minus 4. Plus or minus a by e. So students, when we are taking the a by e, the a is the students is therefore, and the value of e, dear students, that is also 5 by 4. So how can you write this is the students? X equal to minus 4 plus or minus 4 into 4 16 by 5. Now student, this is what? 5 into x 5x, 5 4s are 20 plus or minus 16. This is the students 5x. This is what? Minus 20 plus 16 minus 4. That is x 5x plus 4 equal to 0. And another one is the students 5x minus 20 minus 16 minus 36. These two are the directives. Now we have to find the LLR. So dear students, what is the length of the lattice rectum? Length of the lattice rectum is the students 2b square by a. What is the b square is? The b square is the students 9. 2b square upon a is the students, a is the 4. Yes, a is the 4. Now this is the students, the length of the lattice rectum is the 9 by 2. What is the students? Length of the lattice rectum is the 9 by 2. Yes students, what is the foci? Foci is the students. So just we want, just you have to find the foci. What are the formulas of the student directives? X equal to h plus or minus a by e. Foci is the h plus or minus a e comma k. Center is the h comma k. Okay students? Right now students, we are going to discuss about tangents equation and condition for the tangent and the normal equation. Okay students, and also we are going to discuss about auxiliary circle and a direct circle. Okay students? So in the parabola and ellipse, now also, dear students, the equation of the chord is nothing but, this is the equation of the chord, S1 plus S2 equal to S12. This is the chord equation joining the A and B. In generally, how to find the chord equation? Suppose 2 points are in AB, just we have to take 2 points from, that is y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. But don't we can apply s1 plus s2 equal to s4. This is nothing but equation of the chord. So students, when we observe here the b is constant with a, then it will come like this. What is the students? When the b is constant with a, this is the tangent. So dear students, s1 plus s1 equal to s11. This is what students? 2s1. Suppose the point lies on the ellipse, lies on the hyperbola, that is s1 value is the 0. So the equation of the tangent at x1 y1 is s1 equal to 0. Then also we have to know that the differentiation method. My dear students, the tangent means, what is the equation of the tangent? If the line touches the any conic one and only one point, if the line touches the any conic one and only one point, then it is said to be tangent. Now students, the equation of the tangent, at px1 comma y1 to the hyperbola x square by a square minus y square by b square to the hyperbola, what is the students? To the hyperbola s equal to x square by a square minus y square by b square minus 1 equal to 0 is s1 equal to 0. This is, we know that the equation of the tangent at x1 y1 to the hyperbola. So that is s equal to x square by a square minus y square by b square minus 1 equal to 0 is s1 equal to 0. We have to know also the differentiation method. First we have to take the derivative of this one After that we have to find the dy by dx at x1 by 1, that is the slope. After that point is there, then we can apply the slope point form y minus y1 equal to m into x minus x1. Then we will got s1 equal to 0. So we proved in ellipse and also in parabola and also in circle. Now students, the another condition. The another condition is the students, the line, condition that the line, what is the students? Condition that the line y equal to mx plus c. Dear students, the condition that the line y equal to mx plus c be a tangent to the hyperbola x square by a square minus y square by b square equal to 1 is c square equal to a square m square minus b square. What is the students? C square equal to a square m square minus b square. This is the condition. This is the condition for the line. My dear students, c square equal to a square m square minus b square. Just 1 minute students. How can we prove this is? So when we are taking the students, this is just you can take the tangent. My dear students, this is the p x1 comma y1. So dear students, the equation of the tangents, just we know that is s1 equal to 0. That is what? xx1 by a square minus yy1 by b square equal to 1. So this is given that y equal to mx plus c. My dear students, this will be sending other side. This will be sending other side the mx minus y plus c equal to 0. What is the students? Mx minus y plus c equal to 0. These are 1 and 2 are represents the same lines. 1 and 2 are represents the same lines. That's why you can written as x1 by a square by m. This is what? x1 by a square m. So after that minus y1 by b square by minus 1. This is y1 by b square. So students, this is minus 1 by c. So students, we can written as x1 comma y1 equal to, what is the students? Minus a square m by c comma b square by c. This is what? The point x1 comma y1. x1 comma y1 is the students minus a square m by c comma, what is the students? Minus, yes, what is that? Undoubtedly dear students, we can observe minus a square m by m comma minus b square by c. This is the point of contact. Minus a square m by c minus b square by c. You can observe the students in ellipse minus a square by m by c, but this is the b square by c. So dear students, the point x1 y1 is lies on both the line and the parabola. So this is what students? y1 equal to mx1 plus c. This is substitute here. What is the y1 is there? Minus b square by c. M into what is the x1 is? x1 is the students minus a square m by c plus c. So the c will be sending to the other side minus b square. So students, minus of a square m square. This is what? c square. So students, the c square equal to, this will be sending to the other side a square m square minus b square. So students, this is the c square. C square equal to a square m square minus b square. This is the condition. The line y equal to mx plus c be a tangent to the hyperbola where the point of contact is minus a square m by c comma minus b square by c. Okay students, suppose the students, the line lx plus my, directly we can take same process students. Directly we are taking the line lx plus my plus n equal to 0. Instead of this line, condition that the line lx plus my plus n equal to 0 may be a tangent to the hyperbola is, this is what? A square l square minus b square m square equal to n square. In the ellipse, we observed here, we are getting plus sign. So what is the, you can written as the condition for the line, Lx plus My plus N equal to 0 be a tangent to the hyperbola is a square L square minus b square L square equal to N square, where the point of contact is the students minus a square L by N comma b square M by N. In the ellipse, both are minus. Okay students, right now the equation of the tangent with slope M to the hyperbola is, now we take the another form. What is the students? The equation of dear students, the equation of the tangent. What is the students? The equation of the tangent with slope M. Okay, drawn from the external point to the hyperbola is, what is the student? The equation of the tangent with slope M to the hyperbola x square by a square minus y square by b square equal to 1 is y equal to mx plus c. What is the c students? Here what we observe c, this will be standing other side, plus or minus root of a square m square minus b square. My dear students, what we observed here, there exist the two tangents drawn from external point to the, what is the students? There exist the two tangents. Those are the plus sign, one tangent, minus sign is the one. So students, there exist the two tangents drawn from external point to the ellipse. So dear students, my observation is, suppose this is passing through the x1, y1. So then it will come, how to write this is y1 mx1 whole square equal to plus or minus a square m square minus b square. Dear students, when you can squaring on both sides, we got sum of the slopes and product of the slopes. When this is the students squaring on both sides, this is what? y1 square minus 2x1 y1 m. After then m square x1 square. This is the students a square m square minus b square. So students, you observe here the quadratic equation in m is x1 square minus a square into m square minus 2x1 y1 m. After that students, this is what? y1 square plus b square equal to 0. My dear students, this is a quadratic equation in m. Yes, having the roots m1 and m2. So what? The sum of the slopes m1 plus m2 equal to minus of b by a. This is the students 2x1 y1 by x1 square minus a square. And the students product of the slopes m1 m2 equal to c by a. This is what? y1 square plus b square by, so this is the students x1 square minus a square. Yes students, the sum of the slopes will be the 2x1 y1 by x1 square minus a square. Product of the slopes m1 m2 equal to y1 square plus b square by x1 square minus a square. Dear students, and also we know that tan theta. What is the angle between the tangent? Suppose students, when we are taking the angle between the tangents is theta. Tan theta equal to, dear students, 2ab root of minus s11 upon x1 square plus y1 square minus a square plus b square. In the ellipse, tan theta is the student 2ab root of s11 by x1 square plus y1 square minus of a square plus b square. But here the tan theta is the 2ab into root of minus s11 upon x1 square plus y1 square minus a square plus b square. In the parabola, tan theta equal to root of s11 by mod x1 plus a. In the ellipse, tan theta, angle between the tangents is theta. Tan theta equal to 2ab into root of s11 upon x1 square plus y1 square minus of a square plus b square. Here minus a square plus b square. This is the angle between the tangents. Dear students, this is sum of the slopes. This is the product of the slopes. So dear students, when the tangents are perpendicular, what is the students? When the tangents are perpendicular, how to write here? when the tangents are perpendicular, product of the slopes undoubtedly -1. What is the students? So tangents are perpendicular. Dear students, the tangents are perpendicular. Undoubtedly, that is the students, when the tangents are perpendicular, product of the slopes equal to -1. So where is there? This is. What is the form m1 m2? That is the students, y1 square plus b square by x1 square minus a square equal to -1. This is the students, y1 square plus b square. Then it is x1 square plus a square. These are all sending to the other side. Dear students, what is the equation? We got here x1 square plus y1 square equal to a square minus b square. This is called as equation of the direct circle. What is the students? Is called equation of the direct circle of the hyperbola. What is the students? X square plus y square, the locus of P. The locus of P is the x square plus y square equal to a square minus b square. So we know that in circles and also ellipse, right now in the hyperbola, the locus of the perpendicular tangents lies on a circle and concentric with the hyperbola having the same center. Therefore, the locus of the perpendicular tangents lies on a circle and concentric with the hyperbola. Then the circle is said to be direct circle. The equation of the direct circle is x square plus y square equal to a square plus b square. My dear students, this is the equation of the direct circle. So how to write this is x square plus y square equal to a square minus b square is called as locus of the equation is direct circle. After that, students, the locus of the feet of the perpendiculars drawn from any tangent to the hyperbola is lies on a circle and concentric with the hyperbola. That it is called auxiliary circle. The equation of the auxiliary circle is the students. The equation of the auxiliary circle to the hyperbola is the students x square plus y square equal to a square. What is the students? The equation of the auxiliary circle, that is x square plus y square equal to a square. So students, just you have to take any tangent to the hyperbola is, just 1 minute students, we have to take any tangents. My dear students, when we are taking any tangents, this is the tangent students. When we are taking the tangents, just you can draw here this is the focus, this is the perpendicular. My dear student, this is the S dash, this is the perpendicular. So dear students, when you can observe, this is the tangent. So dear students, this is the AE comma 0. This is the students minus AE comma 0. Is it clear students? What we observed here. So when you can write the equation of the tangent is y equal to mx plus or minus, we have to know that the equation of the tangent to the hyperbola with slope m, y equal to mx plus or minus under root a square m square minus b square. So student, this is y minus mx equal to plus or minus a square m square minus b square. This will be equation 1. Now when you take this is the slope m, undoubtedly this is minus 1 by m. So student, the equation of the lines which are passing through the foci having the slope minus 1 by m, y minus y1 minus 1 by m into x plus or minus ae. This is what? My. The minus x is the plus x equal to students plus or minus ae. Now student, sum of the squares is, how to write this is, dear students, a square, here a square. This is 1 plus m square into y square. In this b square, here b square is m square plus 1. The m square plus 1 into x square. What is the students? M square plus 1 into x square. Minus 2ab plus 2ab are cancelled. This is what students? Here a square is a square m square minus b square. This is a square e square. Dear students, what we observe? 1 plus m square into x square plus 1 plus m square into y square. So students, here we observed what is the minus b square is the form is there a square m square. B square is the a square into e square minus 1 a square e square. So students, minus a square e square plus a square e square cancel. This is minus of minus plus. A square is the common. M square plus 1. Each term is 1 plus m square is there. Divided by 1 plus m square on both sides. This is what? X square plus y square equal to a square. So this is called auxiliary circle. Dear students, they have radius a. That is the diameter is the 2a. That means length of the student's transfer axis. This is called the auxiliary circle. My dear student, that is called as auxiliary circle. So the locus of the feet of the perpendicular. What is the students? The locus of the feet of the perpendicular. The locus of the feet of the perpendicular to the any tangents. What is the student? Locus of the feet of the perpendicular are drawn from the locus of the feet of the perpendicular are drawn from foci to the any tangents lies on a circle. Lies on a circle undoubtedly. So dear students, lies on a circle. Yes. So then the circle lies on a circle. Yes. Lies on a circle, dear students, and concentric with the ellipse. Concentric with the ellipse. Then the circle is said to be auxiliary circle. The equation of the auxiliary circle is the students x square plus y square equal to a square. In the ellipse also, the equation of the auxiliary circle is x square plus y square equal to a square. Okay students, are you understand? Now students, we know that normal is the line which is perpendicular to the, suppose p x1 y1 be a point on the hyperbola. So the line which is perpendicular to the tangent at p x1 y1 is called as normal. So students, suppose when you are taking the tangent, this is called as normal. So which is perpendicular to the tangent at p x1 y1. So dear students, what is the equation of the tangent? Tangent is the s1 equal to 0. What is the students? Tangent is the s1 equal to 0. Then we have to take the slope and find the first slope, then the perpendicular slope, and the line is passing through the perpendicular slope of s1 equal to 0 and passing through the x1 y1. That is the equation of the normal. We know that students, in the ellipse, the equation of the normal at x1 y1 is a square x by x1 minus b square y by y1 equal to a square minus b square. In the hyperbola, dear students, the equation of the normal at px1 y1 to the hyperbola formula is enough students. In hyperbola, all formulas are enough, the proofs are not necessary. So we can prove in ellipse. These all proofs already we can prove in ellipse. Okay students? So the equation of the normal at x1 y1 to the hyperbola x square by a square minus y square by b square equal to 1 is a square x by x1 plus what is the difference of ellipse and hyperbola? For the normal, there is minus is there, here plus a square x by x1 plus b square y by y1 equal to a square plus b square. This is what students? A square x by x1, a square x by x1 plus b square y by y1 equal to a square plus b square. What is the students? The equation of the normal at x1 y1 to the hyperbola x square by a square minus y square by b square equal to 1 is a square x by x1 plus b square y by y1 equal to a square plus b square. Okay students, this is today we discussed about Auxiliary circle is x square plus y square equal to a square, and a direct circle is x square plus y square equal to a square minus b square. And also the tangent condition for the line y equal to mx plus c is a tangent to the hyperbola is c square equal to a square m square minus b square. The tangent is y equal to mx plus or minus root of a square m square minus b square. Then also find the sum of the slopes minus a square. Product of the slopes y square plus b square by x square minus a square, and tan theta is 2ab into root of minus s11 upon x square plus y square minus a square plus b square. Okay students, all of you by heart those formulas. Okay, this is today students. Thank you all.